off we go. So we're playing with big numbers today. And we started playing with big numbers the other day. Big numbers. And the most important thing about big numbers for now is just remembering that we have names for big numbers, and the idea of place value. So,
what would come after a quadrillion?
Quintillion, maybe?
Quintillion?
Yeah, and here's another thing. That's not the same around the world.
No?
No. So check this out. So I'm going to write this number right here. And what would we call that number right there? 1 million, right? Not everybody in the world calls it that.
Well, I mean, obviously, like in Mexico, they call it what?
Well, no, even more different than that. So we group by threes. Every block of three, we give it a new name. So, you know, for example, this first set of digits, that group really are referred to as the ones, but there's also tens and hundreds in there. This next group of three right here, we usually refer to as the thousands. And there's the 1,000s and the 10,000s and the 100,000s. The next block of three are all millions. Well, that's what we call them, right? Millions. Let's pick a bigger number. What would we call this number? 1 billion. And again, from above, this group right here is all three of them are our millions. And we have the 1 millions and the 10 millions and the 100 millions. And then the next group of three is going to be our billions. What's after billions? Trillions, and then quadrillions and quintillions and maybe sextillions. I can't quite remember that one. But not everybody in the world does it that way. A lot of other countries go in groups of 6. So I'm pretty sure France is one of these countries. So this number right here would, instead of being called a billion, this would be 1,000 million.
That's what I was thinking.
And then the one we call trillion, that's what they call billion, because they go by groups of 6 instead.
All right, but so
Yeah.
like 1,000, so a million isn't just 1,000K.
Not everywhere in the world. Yeah, so not everywhere in the world. Here's another thing about numbers: the comma. Not everybody in the world uses a comma to separate those three. So, for example, you might see this in France. That means 1350, where we would put a decimal point. So if someone in France had never seen a US person write numbers before and they saw all those commas, they would say, what the hell is wrong with you? There's only one comma for the decimal, because they think that's what separates the decimal from the whole number, right? So just a side note, the way we call numbers isn't universal throughout the world. The way we write numbers isn't universal throughout the world, even with people, countries that use the same set of digits as we do. Okay, so hang on, question over here.
What would they do if it's like, you know, 1,000 something and a decimal? Would they just have a like big number?
So they put spaces. Yeah, so they would write like maybe 13,057, comma 45. So this would be 13,057 and 45 cents, or 0.45, 4,500, something like that. Yeah. Over here and then
I thought math was like a universal language.
yes and no. The general concepts are universal, but names for things are not. Yeah.
I know, I was just gonna say that I learned that in French class.
About the naming and the comma.
Yeah.
Yeah.
Because like there was a point where we had to like order food.
Yeah.
And we had to write that down.
Yeah. So, okay. So it's good to know, right? The world is way bigger than Oregon, United States, Hamilton, whatever. So my hope is that you're familiar with that there's millions and billions and trillions. After that, not a big deal. So just for fun, the next big place value for us would be 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a lot of zeros. 1, 2, 3. Do I have enough yet? Ones, thousands, millions, billions, trillions. Okay, so this would be 1 trillion. And when like you read the newspaper and they're talking about big numbers, like maybe the budget of a state or a country, the debt of a state or a country, they're not going to use all the zeros. They're going to say things like 1 billion and 1 trillion, right? And not list all the zeros, which is great, right? Because that's a lot of zeros to write. And then you have to look at it and count and figure out what the hell it means. So in speaking to people and writing about it, it's way more instructive and useful to write it this way rather than that way, right? Now, however, when I'm doing math, there is not a trillion button on my calculator, right? So if I need to do a calculation with this, I probably got to type in some zeros, but there's a shortcut for that. The shortcut is called scientific notation. And what scientific notation does, is it uses powers of 10, right? Because we know that 10 squared is 100. And we know that 10 cubed is 1,000. Oops, not 2. Ah. Cubed is 1,000. And I skipped one before that. Like, what would 10 to the first be? It'd just be 10. All right, here's a trick question. That's a 10. What would 10 to the 0 be?
1.
Ooh, nice. It is 1. Yeah, 10 to the 0 is 1. Yeah, 2 to the 0 is 1. 3 to the 0 is 1. Most numbers to the power of 0 are 1. And the nice, what's that?
Close.
Yes.
There's some that aren't.
0 to 0 is a problem.
Oh, okay.
Yeah. And it's a problem for a couple of reasons. I'll talk about that another day.
I just thought there was just random numbers that.
No, there's no rate. 0 is the only one that's a problem. Yeah, 7's
I don't know
trouble.
why,
Yeah.
but it's a 0.
So the nice thing about powers of 10 is the power is related to the number of zeros that you see, which is pretty cool, right? So powers of 10 are nice. They're easy compared to powers of other numbers, which aren't so nice. So in this number right here, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a trillion must be the same as 10 to the power 12 because there are 12 zeros there. Okay. Now that's just a power of 10. To make this scientific notation, I have to multiply something by it. So the scientific notation version of a trillion would be 1 times 10 to the 12. So the general rule about scientific notation, so I'm going to come to a new page here. There's the page. So the scientific notation rule you're always going to have some number times 10 to some power. Okay, so this is my power up here. And then there's some number over here. This number that I write out in front has to be greater than or equal to 1 and less than 10. Okay, so okay, let's play with that for a minute. So let's take a slightly harder number to deal with. Like sometimes in the news, I'll see something like 1.5 trillion. Okay, so to write that out to use on my calculator, I might do something like this, put the 1, put the 5, and then start writing zeros until I have enough. So let's see, that's millions now. Now it's billions. Now I finally have the 1 in the trillions place by adding enough zeros, right? Throw some commas in there. So that right there is 1.5 trillion. Now, at first glance, when I look at that, I would be tempted to write that as 15 times 10 to the power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that really 15? Is 1.5 trillion the same as 15 times 10 to the 11th power? The answer is yeah, it is.
Oh, is that right?
It's true, but that number is not in scientific notation. Why not?
15 times 10 to 9?
Yeah, it's because I didn't meet this part of the rule right here. This number is supposed to be less than 10. It's bigger than 10. So that means the answer has to be for it to be scientific notation. It has to be 1.5 times 10 to some power.
Well,
Yeah, and then if you count to get the decimal here, So that's where I want the decimal to be. I have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So all of these numbers are equal. That number equals this number right here. If I take away that decimal point, oops, that was a big eraser. It's equal to this number right here, and it's equal to, these are all the same exact number, but only this one right here is in scientific notation, because it meets the criteria of the number part is bigger, is 1 or bigger, but less than 12. So what that means is to be in scientific notation, you can never have more than 1 digit to the left of the decimal point. Okay. Otherwise, like this version down here, that's called pseudo-scientific notation. It's kind of scientific notation, but not quite right. Right? What's up?
Way off topic.
Okay.
Did you play any sports? In your high school, college, even?
Okay, hang on, I'm gonna stop the video right here.